Hello, I'm Roberto, and we are learning Rust. Here with me we have,
Luciano, hello everyone.
if you don't know this channel, in this channel we talk about Rust and technologies. You can find a recording of previous streaming on YouTube, and if you're watching this on YouTube, we stream every Monday, 6 p.m. Dublin time on Twitch. Today we are talking about Rust, Neon, and Node. What is Neon? Luciano will tell you, but basically we are trying to run Rust code from Node.js.
I have to tell you. Okay.
Yeah, you tell what Neon is. You share the Neon.
Yes, I'm just going to share my screen and we're going to try to figure it out together. Because right now, what I understand is that basically Neon tries to make a very specific use case a little bit simpler. And the use case is when you are trying to write something in Rust and then expose it as a Node.js library. That could be, for instance, for performance reason, or it could be just because maybe you have already implemented something in Rust and it's just easier rather than rewriting it entirely in JavaScript. You just expose whatever you have done in Rust as a native extension to JavaScript. So that's my understanding of Neon. I know that there are other tools. For instance, Jean on Twitter was mentioning that there is an API-RS with BindGen. Actually, there are two different ones, NAPI-RS and BindGen, which are other alternatives that you might want to use as opposed to Neon. Reason why we are looking into Neon, just because it looks fancy, and we had a quick look at the documentation and it was clear enough what is the API. So hopefully we'll be able to build something functional during this hour.
And it has a nice logo.
Yes, very neon-like logo. So where do we start? Do we just follow the tutorial?
I would say that we follow the tutorial just to do a classic hello world from Rust, but calling it from Node. Then we can go a little bit deeper.
Yeah, I agree. And by the way, if you have questions, feel free to drop them in the chat and we'll try to answer them as best as we can. Okay, so this is the nice website and there is even a video, but we are just interested in the get started tutorial. And of course, the first page is just saying you need to have Node, you need to have Rust, and I think I already have both. So we are going to skip how to install those. Then the next step is that we can actually, first of all, let's mention that we might be doing something a little bit simpler, but if you follow the tutorial, what they want you to build is a module written in Rust that basically just allows you to see how many CPUs you have available in your system. And then that module is exposed so that you can use it in JavaScript. So this is why the example is called CPU count. And we might be doing something simpler just because we already have done this one and we want to try to do something a little bit different. Okay, so there is an npm init command that we can use to start, basically to scaffold our project using Neon. So if we go to the terminal, we can call it playing with Neon. And this is going to create a new folder where it's going to basically do an npm init for us. And npm init is telling us, you are creating a new JavaScript package for Node.js. What is the name of this package? And here we are just going to call it playing with Neon. The version, description, we can leave all the stuff empty, to be honest. We're not going to be publishing this package. Of course, if you are thinking about publishing it, you might want to populate all of these details or at least edit the package JSON after you do this process, just before publishing. Okay, this is kind of an example of the, well, this is actually the package JSON that is going to be generated for us. And we can see that it's doing a bunch of interesting things. For instance, when we run npm install, it's also going to run npm run build release, which is this guy, which is going to run npm run build in release mode. So it's running cargo, CP artifact, all this stuff here. So it is already giving us the scripts that we can use to just use the Rust code to generate a Node.js library. Does it make sense?
Yeah, so if now we do, and probably the tutorial is telling us to do an npm init now, but what do we have now? Before
For an install, yes, good point.
Yeah, before the install, what do we have in that folder?
I don't know if this is readable enough. Let me know.
For me, it is. I don't know in the if.
My Rust analyzer crashed, so I think we'll need to close this guy and open it up again. So cd playing neon code. So now we have.
Is your Rust analyzer happy?
Seems happy. So there is a package JSON, which is the one we just saw in the terminal. Then there is a cargo toml, which also is called playing with neon. Hey, we have Tommaso in the chat. Hello, Tommaso. How are you? Then, interesting enough, there is this exclude index node, which I have a vague idea of what it is, but we will
probably it's the artifact that we will create and then Node will import. Probably. Makes sense.
Then there is this crate type, which I think this means that it's going to compile as a dynamically linked library. And then we don't have any dependency, but there is a dependencies.neon. That's a bit weird that they do it this way. But in general, what you will see is something like neon equal version, blah, blah, blah. This should be the same syntax, basically.
Probably it's the same, yes.
Yeah. Maybe it's just to keep it, I don't know, outside our bulk of dependencies, just in case.
That MPI 6 is Node API version 6.
Okay. Oh, we also have Jean in the chat. How are you, Jean? Good to seeing you here. And yeah, that should be the result of the build. Yes, this index.node is basic. We are going to see it in a second, but it's going to be a binary file that contains all the Rust code compiled in such a way that Node can actually import it. Okay, so next step. Are we happy with this? Actually, let's see the source, because it's also creating some source code for us. We're going to see these details in a second, but there is some structure there that we can just use. Okay, funny enough, cargo analyzer, Rust analyzer is already compiling, so you'll see more stuff appearing there. But anyway, back to the description. So if we follow the tutorial, we can also specify different versions of an API, which I'm not an expert in this, so people in the chat feel free to correct me. But my understanding of an API is basically when you want a programming language, a dynamic programming language such as JavaScript, to be able to import stuff from like compiled languages, like things written in C or Rust, you need to have some kind of interface that allows you to define how do you share memory, information, function calls between these two environments. So this API, of course, is something that can evolve over time. In Node, it was created as an API. This was the name. And there are different versions because, of course, it can change over time and you can create packages that are compliant to a specific version. And if you look in the Node.js documentation, I'm going to drop a link here in the chat. Basically, you can see that, for instance, if you use Node 16, it is compatible with an API from version 4 to version 8. So
but if we also version 1, 2, and 3, because it's a more than 10.
Oh, yeah, that's true.
So basically, Node 16, you can use all 8 versions. If you are, for example, on Node 13, you can use only up to 5 because it lacks 6, 7, and 8. Okay, but we are using 16, so
we are using 16, so we should be fine.
With
so we have another comment there. I'm trying to highlight this comment by John saying this is a good way to start having Rust in the companies while providing a boost of performance. Hopefully, or I suppose even if you have functionality that is already written in Rust and you don't have it in JavaScript, probably an easy way to just bridge that functionality and not rewriting everything in JavaScript.
Yeah, or if you have a library that you can install a crate, you can install with a cargo crate, I don't know, for cap and prot or for encryption, more CPU intense stuff. you can just import that, wrap a little bit with a couple of back and forth, and then call it from Node.
I don't know if we will have time today, but there might be an interesting experiment there. I have contributed to a library called DGC in Rust, which is basically a decoder for the Green Pass COVID certificate. And it's something not too complicated, but there is a bit of logic there that if you have to rewrite it from scratch, it's going to take a while because there are multiple layers of wrapping, signatures, binary encoding, and all that kind of stuff. That if you have to rewrite all of this in JavaScript, it's going to take you a while. So that might be an interesting use case of a real piece of functionality that we already have in Rust that we might think, okay, what's the easiest interface we can just expose to Node.js to have the same functionality there.
Okay. Let's see if we can run the hello world first.
Yes, let's try to do that. So back to the documentation. So we can select a specific version of an API. Now what it's telling us to do is to just do an npm install. And we already saw that if we do npm install, it's actually going to run a build. So it's not just installing dependencies because we don't really have any dependency yet. So it is actually doing this build command. Sorry, Roberto, you were saying?
In the documentation, it explains what the index node is.
Oh yeah, let's have a look at that while it's building. So it's saying that it creates a target, which is something standard in Rust. When you build something, it's going to be inside target. So this is a folder. And then it also builds this index.node, which is the compiled Neon module. At that point, we should be able to do this, run a node terminal, require the current directory. It should load this index.node, and then we should be able to see that it contains an hello function and call it and see hello node. Should we try that?
The compiler is done in the meantime.
It should. Yeah, it is relatively fast. I mean, we're not doing much. Okay, so we have node, so we can call it h dot. So we are requiring the current folder. So it's looking for index files in the current folder. It is finding something. So it is finding this module, which right now contains only a function called hello. So we should be able to call h.hello. And we see hello node. Success. Okay, guys, job done. See you next time. No, I'm kidding. I'm kidding. Okay, we can spend
next step. Can we do something very stupid? So a function that takes two numbers, sum them, and give them back. So let's explore how you take parameters.
I think so, and we have, to be honest, we have already tried something like that. So I'm gonna skip the rest of the tutorial. But in the tutorial, we'll start to explain you how to write code in here so that you can actually bind Rust land with Node.js land. So let's make this a little bit bigger. Let me know if it's not readable enough. And let's see the code that was generated for us, and then let's try to change this code. So the first thing we need to do is import the Neon prelude. So this is bringing all the types that we need to use from Neon into the scope. So we can just use them here. Now, this is the function that we are exposing to the JavaScript world. So functions need to have a very specific signature. They need to accept a mutable context. So this is kind of the way I like to see this, even it might not be the most accurate description. It's like when you run JavaScript, you have an instance of V8 that is interpreting your code. And V8 is making sure that it keeps track of all the variables that are allocated. It's running the garbage collector for you. So you literally have a running context where your code is being executed. So to me, this context is effectively something that gives you access to that execution engine of JavaScript. And you can use it to create new objects, to read the existing objects, to export functionality and things like that. So this is what we need to receive in our function. Then we can return a JS result, which is just an error type, a wrapper type, a result type, which can be either a successful object or an error. And you can see here that this is just an alias for neon result. And we can specify what kind is returned in case of success. So here we are just saying, I want to return an hello world. So it is an OK, meaning it didn't fail. And then the content of the successful case is just a string containing hello world.
Created from the context, so in the JavaScript memory, in the node memory, sorry.
Exactly. And another thing that might be interesting to see if we move this stuff somewhere else. So let's just say let result equal this, and then we return a result. We can see the type inference is telling us that the type of this cx.string is an handle with the generic type as JS string. So you might be wondering, what is an handle? And an handle is kind of a smart pointer that pretty much exposes memory existing in V8 to Rust land. So it makes sure that you are using that memory safely when coding in Rust. So cx.string uses the current context to allocate a string and gives you that kind of pointer back so that you can use it. If you want to get the raw value in Rust, what you can do is something like let's call it value equal result dot value, I think, and you need to pass again the context. Now, why it needs to be mutable, I'm not too sure. I think there might be an element of tracking references or something like that. So probably is making sure that when you do this, V8 is not just going to randomly garbage collect that value while you are still using it. But I don't know for sure. This might be something worth looking into more depth at some point later. So if we want to work with the raw value in Rust land, because maybe we get that value and we want to do something with it, generally you have to extrapolate it from the handle this way. Then you can do whatever. You can produce a result, wrap it again in a new handle, and return it back to JavaScript. So there is always a little bit of dance there that we need to do. I see there is a question. Let's see if I can show it on screen. For some reason, it doesn't let me, but I'm just going to read it. How the error is treated at JavaScript side. Good question. We might try that. Actually, let's simulate an error.
So instead of an OK, we return an error with an empty tuple or with an empty type.
I'm not sure what's the type. Oh yeah, we need to explicitly do something like this if Copilot is right.
But let's try.
Okay, let's try this.
Yeah.
I'm going to comment everything else, and we'll try this. Why is throw complaining? No function associated. Okay, let me try something else then, because Copilot was being too smart. So CX throw error probably will be different. Oh. Copilot, you don't know what you're talking about.
Error.
There is an error. Cool. Error and message. Hello error. I like it. Okay,
but
this is an error. What is it looking for? For a throw. Okay, what is error looking for? Let's look at this type for a second. So JS result could be a neon result, which is an handle BT. But what is a neon result? Okay, is either a T, so this is the successful case, or a throw. How do we create a throw? It's coming from... Okay, we can do throw.new, and what do we need to pass? We don't even need to pass a context. Okay, let's try that then. So if we do throw.new, hello node, is that gonna work? We need to import it probably. Now, is it going to be happy? Oh, function new is private, so we cannot initialize it.
What function do we have on top of throw then?
Sorry, let me clean up the chat very quickly. Okay, so what do we need to throw? Yeah, there must be another way to initialize throw. Let's try again. Does it tell us? Indicating Java throw deliberately does not implement error. It's not recommended to change JavaScript exception with other kinds of Rust errors, since throwing means the JavaScript thread is unavailable until the exception is handled. Okay. It doesn't really tell us how to create throw. Okay, let's pause this one for a second. We'll get back to it.
And you just return a JS error.
JS error.
Yeah.
Throw new. What is this one?
No. Not throw, just create a JS error.
Let me see what a JS error looks like. So, how do you even create it?
There should be
You need to pass a row or local. No, I think this one is probably only for reading errors. Creates a direct instance of the error. Okay.
Convert panic. Okay. But can you return a generic Rust error with an empty type?
Just to do a error like this.
Yeah. What is happening? Is he fine? No, because
it's telling us that it's looking for a throw, but it doesn't have a throw.
Okay.
So
I would say,
I guess the
let's look at this later.
Let me try the last thing, because probably that's what we should have done. So if we look here at the documentation and look for throw, let's see what we find. Oh, not this way. There. Okay. So we can do context throw. Throw is a JavaScript value. Let's look at this one. Sounds interesting. So if we do CX throw, did we try that?
I think so, to be honest.
So if we do CX dot just throw, not throw error, Copilot stop it. Okay, is that going to be enough? Why doesn't like it? Is expecting, oh yeah, because it needs to be a CX dot string. That's probably what we missed. It still needs to be a JavaScript type, right?
It talks about enumerations. Expect struct throw. I found an enumeration throw. So they are two different kind of throw.
Wait, is this already just throwing?
Cannot borrow CSS mutable more than once.
Okay.
Yeah, but take a reference to
Now is happy.
Okay, now is happy.
Okay, let's compile and try this one.
Oh God, what's happening now? To compile, you have to do another npm install. Yeah.
Now Node.
And now there is an unusually import, but okay.
Okay, so we have h.lo now should blow up.
Uncode. And if you do put that in a try block,
h.lo. Yeah, it is.
Undefined. Okay.
Cool.
No, sorry, it's an error OMG.
Yeah, it is console erroring it.
Yeah.
And then undefined is the result of this.
Is the result of your expression. Sorry.
Okay.
I'm done with Node.
Yeah, cool. Sorry, Tommaso was giving us a bunch of suggestions. We just ignore it. Sorry, Tommaso. Please keep suggesting us. Okay, you are saying try to put it into a function to see if there is the stack trace. I think what we can do is
create a node file, JS something. I want to put all of these in a function. Write some node.
Oh yeah, I see what you mean. We can do this, and then we can say function boom is just calling h.hello, right? And then we call boom. It doesn't seem to have the stack trace, right? If we do try boom catch e, there is a way to do e dot.
Don't ask me about node.
Yeah, please. Something like trace. I don't remember it. If we do this console, this is not going to give us a stack trace.
There is a console.trace. No.
Oh yeah, that's giving us the trace.
No.
Yeah, there is this run in this context. I'm not too sure how useful is this, but it's not telling us much about Rust, to be honest, as far as I can tell. Oh, there is also dot stack, you're saying. E dot stack.
Undefined.
Undefined. Is it a function? No.
Even if it was a function, it would not be undefined.
Okay, let's pause this topic for a second.
Let's go back to creating a function that takes two numbers and gives back a number.
Yeah, so what we want to do is fn sum, and we need to copy the same syntax. Cx
Mutable context.
Function context, and it returns a JS result.
Of a JsNumber this time.
This time it needs to be a JsNumber, which is a generic type that, ooh, look at Copilot. I think this might be right.
Yeah, I think so.
I think this time is remembering what we did before. Okay, so
and
we're just gonna...
we have to export the function.
Yes, we're just gonna trust Copilot and go over this implementation really quickly. So what we are doing is the first issue we have is how do we extrapolate function arguments, right? Because somebody's gonna call this function passing some arguments maybe, or 0 arguments, n arguments. You know that in JavaScript you can be very flexible and decide to pass as many arguments as you want of different types. So in Rust, we are a little bit more structured. So we need to have a way to extrapolate these arguments and understand their type. So what are we doing here is saying cx.argument. So from the context, get me the argument. And I want to read it as a JavaScript number. Then 0 means give me the first one. And then this is basically saying, if you cannot extrapolate the first argument, either I am assuming either because the type is wrong or because it's not present at all, this will create an error and the error will be bubbled up and returned. But if we are able to get it, we also want to extrapolate the value just to get the raw value in Rust. And this is going to be
if we stop there, we will not have the number in Rust, but we will have an handle to a JsNumber that will still be in the node memory.
Yeah. So let's
when we do dot value,
that very quickly.
Yeah, exactly. That one is just the number.
Row. This is going to be an handle of a JsNumber. And then
so it's not in the Rust memory, it's still in the node memory. Then with value and the context, we move or copy, or not copy, yes, because I think we are not moving anything.
I think it copies, I will guess it's copying the value.
Probably.
Okay, so we have
same for the second number. Same for the second number, and then we return a JsNumber made of A plus B.
Quick thing, there is a comment in the chat saying error management is always hard. You have to build it on your own Rust to generate your object to send it back. I never found an easy way. Okay, I don't know if that's reassuring, but thank you for mentioning that. But we need to spend more time with the library and see exactly if there are, I don't know, methods
Clean ways of giving errors. Yeah.
Okay, so I think you get the feeling how this one works. Now there is another step that is important, is this is just a function that exists in Rust. How do we expose it as part of our module in Node.js? When Node.js imports it, this function needs to be exposed somehow. And this is where this neon main comes in, which is basically the idea that when you import a module in JavaScript, it gets evaluated dynamically. So you can run code that is executed when the module is imported in the first place. So here what we are doing is basically running this Rust code and populating the context with the things that we want to export. So this time, rather than exporting a hello, which was our previous function, we want to export sum, well, a function called sum in JavaScript that is a reference to our sum in Rust.
We can still export the old hello, but yeah.
Yeah, we could export, of course, multiple functions. I think we could also export constants. I imagine everything that you could export in JavaScript land, you can do it here. But this is where you need to do that wiring of defining what's going to be present in the module at import time.
As public, because you can define functions that are private and not export them, but still be able to call them.
Exactly.
So
okay, so let's npm install node require, well, let's call it h equal require this, and now this time it's giving us sum. So actually I want to see what happens if we don't pass anything. Not enough arguments. Now if we pass blah, it should tell us that it's not able to convert blah into a number. Yeah, failed to downcast any to number. That's interesting. And now if we pass 1, it should fail because the second argument is missing. Now if we pass 2, we should get 3. So this seems to work as we expect.
Okay. Now, do you want to try to pass an array of numbers to the function?
Do we want to pass an array of numbers? So basically we want to make this dynamic so that a user can pass as many numbers as they want, and we will basically accumulate all of them and return the sum.
Take every number, make the square of it, and sum all of them together. So it's a dot map and a dot sum in Rust.
Okay, so we also want to do the square. Perfect, let's do that.
Yeah, just do some computation on top of the number, not just sum. Do something.
Let's call it sum square.
Yeah, if you are able to think of something more complicated to put a little bit of stress on the CPU, but let's start with something simple. We can always, I don't know, do something harder.
Okay, so here, what do we do?
Copilot,
we need to extract all the values. So let's see if there is an iterator that allows us to go through all the
in the documentation of Neon, let's see if we have an array type.
Oh, you want to pass a row array? I was thinking, because in JavaScript you can also pass them as row arguments, not necessarily as an array.
Oh, what is simpler, the array?
I don't know. If we want to explore the array, we can use the array. Otherwise, we can check if there is an easy way to get an iterator over all the arguments.
No idea. What is easier in your opinion?
Let's start with the iterator over the arguments. Then if we want to see how to read an array, we can also try that. So cx dot argument
Argument is giving you one argument.
Okay,
What
maybe there
else
isn't
can
an
we
easy
have?
way.
Because
Yeah,
you have to give I, and I is an integer, so is the...
Yep, I don't think we have an iterator there. We could probably build one, but I don't know if I want to. Because we could do just a loop and continue until there are arguments, right?
Yeah, but let's look in the documentation if we can pass an array.
I think we can pass an array, and I'm gonna guess, and then we check the documentation. Let numbers, let's just call it, and then what we do is cx dot argument JsArray 0. Yeah, that's what we wanted.
Then we have to call value to get the... How do we make the JsArray uniterable in Rust?
So let's just call it numbers dot row, right? And now it's gonna do that, so it stops complaining. Now what we can do is row to vec. Is that gonna work? Okay, now the vector is of handles of JS values. We don't really have a specific type. We don't know yet.
We have to do a map on top of this to call the value mutable CX. Okay.
Because in JavaScript, you could have an array with values of different types.
Yeah, so but here we want only numbers, yes. So
JsValue could be any JavaScript value. Okay, so now what we can do? We can do for... Actually, let's use the...
Can't we map?
Let total equal numbers dot iter dot map, and at this point we can do n. Let's see. Too much crap. What we want to do is downcast JsNumber. Is that what we want?
Downcast. We don't want just n dot value.
I think
it doesn't know the type. It doesn't know the type of JsValue. Yeah, because as value of what? Is value, not dot as value. Is as value or value?
Okay, let me do this. So this is a JsValue. We need to look into JsValue to see how to convert it into a specific value. So JsValue, let's go there. What do we have? A JavaScript value of any type.
Yeah, we just want to go to a number.
Is type of other value. Okay. Okay, let's look at the other docs. Maybe it's going to tell us something different. Let's see, types, I guess.
There is a JS array down there.
Okay, we have upcast and downcast. As array, object downcast or throw. JsValue, this is the top of the hierarchy and can refer to any JavaScript value. For TypeScript programmer, this can be taught as if similar to TypeScript unknown type. Yes, makes sense. JSObject, this is the top of the object type, which implements object. Okay, we are on this line. JsValue, how do we use JsValue?
How can we go from a JsValue to a number? We expect a number.
This is what we were looking at before, and I don't expect it's going to tell us much more than that.
As value takes what as a parameter?
As value, where did you see that?
Scroll a little bit more.
A context. Mutable context. But it returns
then,
an handle of a JsValue again.
So again, there is an infinite loop here.
Let's see if this upcast and downcast tells us something useful. So for instance, here is taking an array, which is an handle of JS array, and is calling upcast to get an handle of JS object.
So it's going one level in the, above in the hierarchy. We have to go down the hierarchy.
No, I think this is what we need to do, because we have
no, we have a value that is a single value of the array, and we have to downcast that to a JsNumber. JsNumber in the hierarchy is below the JsValue. A JsValue can be anything. Can be an array, an object, pigeon.
Okay, instead, let's see this.
We have to go down to the JsNumber that is down here.
Mm-hmm. Okay, let's see this case then. Let's see downcast. Method requires a runtime check to test a value type at runtime. It can fail with a downcast error. So here what they are doing is taking as array, they take an object which is a JS object, and they downcast to array.
Yeah. So can we try to declare that we want to downcast to JsNumber?
If I understand this correctly, yes. So
where is our code?
This is not our code. Yeah.
No. Okay, it's called
this is our code. So it's called n, and we want to say let value, which is going to be an handle of JsNumber. We want to do n downcast.
Yeah. And pass the context, because a reference to the context.
Pass the context.
A mutable reference to the context, like always.
I imagine. And then this can fail. So for now, let's just do unwrap.
Yeah, because the downcast can fail.
Okay, this seems to be correct syntax. I'm going to make this a little bit smaller. Let me know if it's not readable.
Then we have to do the value, value.value again to get a Rust F64.
Okay, let's call it n as number. Or let's just call it n row. And then we do let value is equal n row.
And row dot value, and pass the mutable reference to the context. So at this point, value is
what we return.
No, we do value multiplied by value to have the
square. To do the square.
And with all of this, we sum at the end of this, because it's a number iter map sum.
Yes, and this should give us a F64, which doesn't understand, because either we do it here with the turbofish or we do it here. I prefer it here.
And then we return not total.
Now we don't need to return total, but we need to return number total.
Okay. And we have to export the function to make it happy.
And we need to export sum square. I'm going to do another one, sum underscore square. Actually, because it's JavaScript, we do this, and we call sum square.
Okay.
So you can see that you can also change the name if you want.
Yeah. Is this going to work?
Let's find out. npm
Remember to npm install. Yeah. Okay. Because
it's complained that we are not using a law anywhere, which is fine. It's true. Now we do node. We do h equal require. I don't know why I'm calling it h, but whatever.
Because it was a law. So
okay, maybe.
The name of you changed the name of the function in your export, or?
Yes, I did.
Okay.
And I did it explicitly because in JavaScript you would use camel case.
Yeah.
Case. Okay, so num square, we need to pass an array of numbers. So if we pass 1, 2, 3, 4, whatever, 5, it's doing something. I don't know if it's correct, but I would assume so. Now, if here we pass blah, this is going to explode in a bad way, I think. I think it should just panic because we have an unwrap somewhere.
Let's see.
Yeah.
Yeah, he panicked. And we are not retarding an error because if you were doing a question mark, was then bubbling up properly or?
I don't know, because here we are in a map. So I'm not too sure what's the best way to do this in Rust.
You can put a question mark instead of the unwrap.
Let's try. Let's try if it gets done correctly, even inside the map. No. Because the question mark, I think, gets the current scope, and the current scope is disclosure. So it's gonna kind of bubble up there, but I don't think it makes any sense. So I don't know if there is a good way of handling this with the map.
Let's not handle that for now.
We could have done a regular for loop, I guess, and created a vector, and then done the iteration on that vector. Oh, we have Federico in the chat. First time chat.
They say you can get the result, map result, and do the square inside the map and collect it to a result of 64.
You can get the result. Oh yeah, that's a good idea. So we could do a double map, basically.
And if one of the result is an error...
But then we have the same problem that how do you bubble up? So yeah, what I would prefer is to do something like this. So we call this raw numbers, right? We do let mute numbers as a vec of, I don't know, U64, sorry, F64.
Why mutable? Because
we'll need to push stuff. And we can do vec with capacity, because we know the capacity, which is raw numbers.len. On Copilot, we can do it. And now we can do a regular for loop for n in numbers. Okay, I think now we can use the question mark. No? Should we do or throw? Or throw is
reference mutable.
Is that gonna work? Oh yeah, there is an extra parenthesis there. Okay, that seems to work. So now we have the numbers, and now we can do, basically we don't need to do all of this anymore. We can just run some
on top of n.
I don't know if that makes more sense. By the way, Federico, if you had a different idea and we didn't get it, feel free to write back to us. Okay, so now if I'm gonna try this very quickly.
With a lot of numbers, not with 5 numbers in the array, with a lot of numbers in the array, we can write the same. Luciano?
Did we lose Roberto? I don't see you anymore. And I don't know if I can hear you. Okay, I think you're back. Can you talk? No, I cannot hear you. You are in the room, Roberto, and you are not muted, so I don't know why I cannot hear you. Meanwhile, I'm gonna keep going while you figure out your microphone. Hey, John, good to have you here. See you next time. Okay, so meanwhile, I'm gonna try this one here. So we do h require and h square with blah. This time it shouldn't panic, but it should give us a proper error. And this seemed to work fine, as we expected. Okay, so they are telling us in the chat that they can hear us, and now I can hear you as well. So, mysteries of live streaming. Sorry, everyone. Okay, now I just tested that if you see in the screen that I recompiled, we run the function again with something that is not a number, like a string, and we get a proper error. It doesn't just panic the entire thread. Cool. So what do we do next? Oh yeah, we lost Roberto. I'm gonna add you again. Let's see if Roberto appears. Should be back in a second. Hello, Roberto. I see you again in the stream. Okay, thank you, Federico, for reporting the technical issues. Hopefully this time we have Roberto again. So we have tested that everything works. What did we want to do? Do we have...
I was asking, what happened with a lot of numbers? You can write a small JavaScript file that Node can execute. You can redo this logic of taking an array of numbers, doing the square and summing all together in JavaScript.
Yep.
We have the function in Rust. We create an array of a lot of numbers, and then we try to see which one is faster. Probably there will be not a big difference here.
Okay, let's
just to see if there is any difference.
Let's do that. So let's do.
Don't call it index because I don't want when you do require dot. If you call this index,
Rust.js, right? So we do this and we call it I don't know, const h equal require this, and then actually let's generate the numbers. So how do we generate numbers from, I don't know, 1,000 numbers?
In Python, but even more. In Python is list range and 1 million. You have an array with 1 million numbers.
I wish you could do that in JavaScript. Okay, let's do let actually const numbers equal this, and then we do for I don't know,
not 100, add some zeros there.
100,000.
Yeah, push I and done.
Push, so it numbers from 0 to 100,000.
Yeah,
basically.
Why not?
Okay.
Numbers are numbers.
Is the square of this one gonna overflow?
In an F64, there is no concept of overflow because it just loses precision.
Okay, so it should be fine.
Rust is fine. We can lose precision, but we are not here to look at precision because we are not casting to U64 or to anything. We are
okay.
the def.
Export.
And in JavaScript, again, I think all numbers in reality in JavaScript are floats, so it will just start to lose precision.
Okay, so const numbers equal require numbers, and now what we can do is sum. Why reduce? Calm down. Sum square is equal to h dot sum square of numbers, and then we console log sum square. Now, if we run this one, it should be pretty much equivalent to what we just did manually, but with 100,000 numbers. So if we exit here and we do node, what did we call it again? Some Rust. Ooh, reference S is not defined. What did I do? Where is it? Oh, sorry, just type it. That one makes sense. This was fast. So fast that it didn't even give us the time. Okay.
Okay, cool. Try to write the same in JavaScript.
In JavaScript. So we do copy paste this one.
Some Node, some JS. I don't know if.
Let's call it pure.
Oh God. in pure JS.
Okay, so what we want to do here is const total equal. I guess we can use reduce.
But do n by n, not just n. On the right.
We need to do n multiplied n. Yes.
Starting from 0. Cool.
0, and we console log total.
Now, this is super stupid. It can be that V8 is faster because there is no translation between types.
Let's try.
And then if it's too fast, let's put another 0 there. Okay, nice that we have a different result. Why?
Yeah, I am concerned of this result.
Oh, God.
What did we do wrong?
Okay, now I will do that in Python to see which one is correct. You went from 0 to 100,000, correct?
0 to 100,000, yes.
Okay. When Ubuntu starts.
So I am... What did we do in Rust? Did we do some mistake there?
Show me the numbers again.
The numbers results. Again in
the two results. The console.
Oh,
yeah. Python agrees with JavaScript.
So we must have done something silly in Rust.
Yeah. Okay, what we did. Let's go back to the Rust code.
I mean, it's still quite fast, but
but if you're doing the wrong stuff, it can be fast as you want. But you must be fast and correct.
So what did we do here? We are reading the numbers.
Are we pushing the square or just the number? We are pushing just the number. You're not doing the square.
Fair enough. Okay. Well, let's do value multiplied
by value, by value. Okay.
Okay, now we need to build again. npm I. And we do Rust. Okay, now we see the right number. And we do pure. Actually, JavaScript is faster.
Because this probably is not enough CPU intensive, and all the transfer between types that we do with the downcast and all the stuff to get to a Rust type is taking time. So probably there we lose. We should have something a little bit more complicated than a multiplication.
Yeah, also, to be fair, we are passing 100,000 objects from JavaScript to Rust.
Yeah, I don't know how the memory works there.
I mean, it doesn't feel like the right way of implementing this. I suppose ideally you would want to pass as little as possible. So maybe a different interface could have been just you pass just 100,000 and they would recreate the numbers in pure Rust and just return the value. That's probably where we will see a bit of a difference.
Yeah, there is always a little bit of tax to pay when you move data between context or between languages and so on. But again, we were able to call Rust from Node. What we could do, but probably we are running out of time, is this can be parallelized. If we use library like Rayon, no, it's called...
There is Rayon, which is something we wanted to use for a while, so let's give it a shot.
We can declare Rayon as a dependency of the Rust code. Then we go back to the .iter, because you have to go back to the .iter implementation, not with the for.
Oh, yeah, we are gonna...
Fine, why not?
I'm not too sure how we're gonna deal with errors in an easy way, but yeah, let's try.
Let's not deal with errors for now. I just want to see if it's possible or not.
Wait.
No? It's not called Rayon?
Oh, cargo add. Yeah, cargo install is trying to install an application into my system, but Rayon is not an application, it's a library. Sorry, I'm mixing up npm install and cargo add.
Yeah, I have lightnings and thunders around North Dublin.
Wow.
So
here is still a bit raining, but still fine. Let's see.
They were thunders. So if I go away, you know why.
Okay. Fingers crossed. So We have Rayon. I don't even remember how to use Rayon, so let's bring up the documentation.
I think it's quite straightforward. Instead of use .iter, you do dot.
But we need to
something
import
else.
the prelude, I think.
Yeah, I don't remember that one. So
okay, Rayon parallelizer, Rayon prelude. So should be easy. Give me an example, please. Use Rayon prelude. Okay, let's just wing it. Why we have all this stuff? We don't need.
oh, probably we did something and the auto included.
Okay, now one quick version would be.
We have to go back to the .iter on top of.
We could do just the sum, but no, I don't like it. So we could do, yes, let's just go back to the map version.
Yeah.
So let's comment this one out and let's just do
raw numbers dot
total equal raw numbers dot iter.
But now we have to use the pariter. Yeah, exactly.
And now we can do map. And map we can do.
We take n. That will
and,
be a
sorry,
JS
let
value.
me close this guy. And we can copy basically this one, which we are just going to use unwrap because at this point we know we don't care. Okay, this is an handle of a JsNumber, then value, and then value.
By value.
And this is the total. We want to do sum as well.
Yes, and then we'll just return. Remove line 38 or comment it. I don't know.
And we return.
Now, pariter is complaining about something.
Exists for vec handle JsValue, but its trade bounds were not satisfied. The following trade bounds were not satisfied. I suppose because we have to use that context and it's a mutable reference, we cannot parallelize that easily.
So we have to provide already the array with numbers. So, we can try to comment this code and comment the first block instead of iter.sum. You do what you do.
Well, we can only parallelize the sum, which I don't know if it's going to speed up a lot, but it's worth trying.
No. Push a value instead of pushing value by value. Push value. Line 26.
Line 26, okay.
Just push value.
Right. And then here we do
go
numbers.
Down.
This is numbers.
Yeah.
Pariter is just going to do
pariter map of just that.
And multiply n.
Yeah. Sum. And then we return total. Now it's complaining
why you're
about...
not happy? Oh yeah, now it needs to know that this is an F64.
Okay.
Because sum is not specific enough.
Yeah.
Okay, and this should be working, but
I don't know if it will be faster or not.
Yeah, I don't think we are gaining too much, but let's try.
No, I don't think. With 10,000 numbers, probably not. But let's try to see if at least it works. Here, we still have a lot of thunders, guys.
Okay, so time sum rust. A little bit faster, isn't it? So 4778 compared to 52. So we gain something, but not too much.
Try to add a 0 to that numbers.js instead of 100,000 to 1 million.
Okay, and just compare the two.
Yeah.
Okay, pure, we go to, sorry, numbers we go to 1 0, so there.
Yeah. So, and then we run the Rust and the node.
So this is 112, and the pure one It's still faster.
Okay, still faster. But again, it's working.
Yeah, now that the other thing we could do, just if we want to be sneaky, to be honest.
You installed it, right, before running? Yes.
Yes, I did.
Yeah.
So what we can do here is fn sum square n, right? And we just pass the context.
Now
all of this is the same.
Outside.
Okay, so what I want to do here is we just pass one number. We pass like either 1 million or 100,000, and it should build everything on its own.
Okay.
But how many? And we do this.
Sorry, I have to open the door to the cat that is scared by the weather.
We do as you sides. That's gonna work? Cool. So now we can do 0 to how many?
Dot parameter.
Where are we starting from 1? In
No,
here?
in we are
No,
starting
from 0. Okay, so this is the same range, exactly the same range.
Yeah, excluded 1 million.
So now we can do pretty much this, right? We can do, sorry, this,
that one. Yeah.
all of that.
Yes.
So let total F64 equal range
dot. Too many
where n is going to be
a number.
I'm trying to see if we can do this as an F64 already.
Do that as a U size. Make total a U size. But make totals a U size. Who cares?
Well, yeah, we'll work the same. Why did I delete it? Okay, why it doesn't like it? We need to call dot either, I think. Oh. It doesn't have an either.
Perché il cellulare?
Vai via.
Va bene.
What is not liking this time?
Parallelize exists for range use size. Oh, really? Because it's an iterator?
It's a generator. It's not. The data are not materialized in memory. But collect a vector from that range.
Okay, values equal vec
of U size. Can you collect?
I think so. Why it doesn't have? Okay. Now we can call values. And why you don't like sum? Because
make total a U size. Because in the end we are returning a cast to. You have to return also the OK.
Yes. And
because in the end we are going from a something in Rust to a JsNumber, so the type is lost.
Okay, now
I don't think do you need to say total as F64 or can you just go with total?
I think we need to do F64 because numbers JavaScript are F64.
It takes a thief, to be honest. Into. You must be able to do an into.
An into F64.
But so do you need to do the as or
I don't know. Oh, if it was another type of number, it would have worked.
Oh,
but I don't think it has the U size. So whatever.
Okay, do that manually.
So sum square n. Let's just call sum square n. And now in some Rust, what we want to do is don't use numbers anymore and do sum square n of
1 million.
1 million. Okay.
Install.
Now we install and run both. So we do the pure first. So this is 62. And then we do Rust. Okay, now it is much well, not much faster, but 62 against 42.
And
but it's a different value. Wait. We did something wrong there. Are we skipping one number or something like that?
You go to 1 million. Let me look what Python say. Python say that the correct one is Rust.
With 0.
Yeah, with 5 and 0 in the end. So JavaScript, for some reason, is wrong. Can that be rounding? I mean, remember the JavaScript rounds integers.
No, it was off by one error.
I know.
It was adding one more number. I just fixed it in JavaScript.
Okay, sorry. Yeah.
Okay, cool. So I think this is probably a good...
And can you do one last test?
Okay.
Instead of doing the par iter, just the iter? Because with par iter,
oh yeah, and 40. Then let's see if par iter makes a big difference.
Let's see if par iter makes any difference in the
so
lib.
In lib, we just want to use iter, right?
Yeah, just curiosity. You have to install.
I love Rayon that you don't have to change anything else. Okay,
and then you run
now
again.
Time Rust 4047. So
okay, so par Rayon
is really not buying as much. Yeah.
No, okay.
For some interesting reason, I don't know why.
I don't know why, but it's not buying us anything.
It's even faster now.
Oh.
36, 38.
Okay. Probably the task of making the square of a number is not complicated enough for this. But still, we were able to use Rayon out of the box with no effort at all.
Mm-hmm. Which is pretty cool. And also, I think Neon was relatively easy to use.
Yeah.
Which is also interesting. So if I were to expose any Rust functionality to JavaScript, Node.js, I would probably consider something like this.
Yeah, because you can take a library that exists, just write this layer of back and forth between types for Node to Rust. That makes sense that you have to write a wrapper layer around a function. And then you have your Node-ready library that in reality is running under the hood Rust. The only problem is that when there is a transfer of data between the two, you can lose some time there.
Yeah, you spend a lot of time converting data, copying stuff in memory, probably.
Yeah, but it's the same when you do Numba and CUDA with Python. If you start to move memory between the GPU and the CPU, you lose time. So you have to do all of your computation in the GPU as long as you can, and then move the stuff only once.
Yeah, or as we did, try to minimize the number of things that gets passed around. So if you can generate the same information in the native land, it's probably best to do that.
Okay, we wrap up?
Yes. So
okay, so you can find the recording.
Yeah, go for it.
You can find the recording on YouTube, the link in Twitch on the About section. If you're watching this on YouTube, we do live streaming on Twitch every Monday at 5 p.m. UTC or 6 p.m. Dublin time with the current day saving. Make sure to check the Twitch link in the YouTube description. Give us a follow so you can be notified. Feel free to leave us comment, open pull request. Are we putting this in any repository, Luciano? Probably.
I will make sure that if you're watching this on YouTube, there is a repository there.
Okay, everything is well accepted. We are trying to learn Rust, so don't expect our solution to be the cleanest or more idiomatic ones. If you know better ways of doing stuff, please tell us. We are here to learn. thank you for all the suggestions in the chat if there's still some back there.
I have a quick announcement because I'm going to be on holiday for a while. I think we'll be resuming the streams at some point in June. So just be aware of that. But still follow us to be informed on when we restart. And if you have any crate in Rust that you would like us to explore, also let us know, because I think it's nice to receive suggestions and try things that you would like to see.
Cool. So see you next time.
And thank you very much also to Didi for following us. Hopefully we'll see you next time. Okay, I'm going to do a raid to Luke, who is always doing interesting stuff. So if you're curious about, he's generally doing either JavaScript, Go, or building his own programming language. So definitely you're going to find something interesting there.
Who is not building his own language? Come on.
Well, I don't know if he's going to be using that in production, but it's cool to try something and learn new stuff. See you, Federico.
Bye.
Thank you for following us. Bye.